I'm going to do a short stream today. I'm gonna try to go over Clap, which is a Rust library with the debugger. I had an agent set it up, then I tested to see if it's working, and it was working, but then I had to change more stuff. So this last one, the last time I didn't check, like the last version of the implementation, so I'm gonna check now. And I updated the way that the report file is done. So basically, I had an agent. I discussed with GPT first. Then I had an agent. GPT gave me a prompt to send to DeepSeek to build this census here. And the way that it works is basically just going over. I also moved the libraries that I have from an external folder to an internal folder here. I think it makes more sense. It basically goes over these folders here. It goes over the corpus. The corpus are the original files, original repositories that I want to study. And the edit is other repositories that the report found that are important. It's basically a bunch of Rust libraries, and then the code goes over and creates a report based on frequency. And this is the result that I'm getting, which is the new format now. I haven't looked into it yet. It's basically saying that 30 and 30 JSON are the ones that are used the most. Basically, this is the frequency of libraries of, yeah. How many times each library is used on all these other libraries I have there. Then there's also, so this one is for external runtime. These ones are for external dev dependencies. Then dependency bundles. And corpus graph, most connected libraries. But yeah, it's saying that it is 30, however you say that. But GPT told me to do a different order there. That's why I'm starting with Clap, because that's the order that GPT gave me 5 initial ones, which I had an agent do the configuration, launch the JSON configuration. So maybe I'll go over the list that I have here after. Then there is also the types that are used the most. Then the methods of the types are these ones. Then transformation chains. It's basically collect, enumerate, then iterations, kind of obvious. Then these other ones here. But these are the traits. Generic types. Type system construct, ownership and memory. Language constructs. A standard library. So the idea is to go over the libraries now manually with the debugger. Then maybe write down some questions or on the last iteration that there was a notes file, but I think that on the most recent one it's removed. It's fine. I can just do it on Notepad. So these are the configurations. This is to debug the main project, and then the other ones are for the projects that I'm gonna review next, probably. I'm gonna start with Clap, then I'm gonna think about whether or not I do the other ones. this order. I think it's probably fine. Then as I go over them, I'm gonna try to write notes about what I think is weird or relevant, and then and also try to understand library as a whole. Then once I spend enough time doing this across all libraries, then I think I'm going to start trying to build the manual exercises that I can do every day to train. And I think these other files here, they contain like all the specific patterns of what happens most often. It's very nice. Okay, so I'm gonna go over. Well, there's also this dependency graph of the libraries. It's extremely confusing. I have an idea of how the dependencies are connected. I'm gonna press F5 to start. And something that I have to see there as well is that initially it wasn't stopping in the main function. So I had that agent do some change here. I was trying to do some other command that I found on Google, uh, which I think is stop at entry. But then when you use that flag here, it stops on the assembly code, and then it looks like either it doesn't go to the Rust code or it gets very confusing to know what's the entry point. So I think that these pre-run commands here make it stop on the. But it's actually setting on the like specific line. So maybe I think this is only useful if you have an agent, because then the agent know what's the file, the entry point file. And the reason why I wanted to have that obviously is because then I can know what the executable is. Like what's where the executable is coming from. Because some projects have a lot of crates, even though I have the path here of the work folder, don't really know like what executable it refers to. Okay, so I'm gonna start with F10 first. And I did one very fast on the first time that the client set this up, or DeepSeek set this up, but I really didn't learn anything. I think what Clap does is allows you to parse this command line arguments that the program receives. It's probably the most used one. But this is kind of sucks as well. Let me think about this. Because I think that I can't do F10 or is F12? Yeah, F12 to go to the definition because it's probably not manually compiled. I guess. Not sure. I'm gonna go with step over and not step into most of the things. But I still want to see like the main functions. I can't go. So this is the first thing that I'm gonna write down here. I'm gonna ask GPT and then try to have DeepSeek fix this, or figure out how I can manually build to fix. Also, another thing that I can do here is look into the names, the variable values. And the problem here is that uh, this one is kind of easy to understand roughly what is going on, even though I don't know the details. But as like the code is saying, they're just looking for different types of flags, like different types of patterns. And I think that the main patterns are either you have two dashes and then the whole thing, or you do one dash and then only one letter. But what I want to clarify more is how does it work when you're using the library. So because I know, like from what I vaguely remember, you create an enum, and then based on that enum, you get the arguments, then you match them, and then based on that, you determine what pattern you send. But I wanna clarify the relationship between the thing you put on the enum and the pattern, the string you put on the command as you're running the program. And it's not very helpful to understand this. Like another problem is that there's like too many things that might be unrelated. I think I'm just gonna try to do F10 faster. And I also think that there are like more than one. I'm on this clap builder, and I think there are other two here. A clap builder, clap bench, clap for benchmark, and complete nutshell and derive. And so there are all these different sub projects here. I think they're like different crates. I don't understand the difference between them as well. One question that I gonna write down that came to my mind when I saw that sref. Why do what is the purpose of the sref function? Why not just use the operator? Because it looks like that function is used a lot as well. Something else that I want to understand is what is the relationship between the code and the operational system when it's running the program? Because obviously the OS is gonna run the program. It's gonna start the program, but then how does Rust capture the environment variables from that? I'm gonna write this down. Obviously, I assume that it's gonna be an API that they have in Rust, but I wanna clarify how does it work under the hood. But obviously, like it's gonna be uh, some part of the language or a library that's gonna be converted into assembly, and then the assembly is gonna call the sys libraries, system libraries, and it's gonna be something like that. As this thing here, this is gonna be another library, the standard library, but I can't go on the stuff. F12 doesn't work. This is another thing that like this thing is called a lot. I don't understand what is like why does it call this the shifting. So I think it's just checking to see if it sets or not, and then it's using some boolean thing to do this. So when you end with 0, then it's gonna be true. This means it's gonna be different than 0. It's gonna be. Not sure how, like, if that's how it works. So I have shift by the self. That part is the one that I'm not really sure what does it means. But I think that is gonna be different than 0 if it is set. But then, like, what does that mean? If you shift 1 by 1, it's gonna become true, I think. So when you end here, I think it is different than 0. I don't know. I have no idea. I don't know if it would be like 1 0. A percent ends with 0 0. Then obviously this is false. Because 1 a percent ends 0. Well, this would be 0. So it would be different than 0. Yeah, so yeah, I think I understand. So when you end the 0 with this and is 0, that means it is sat because it's different than 0. So when this is not sat, this is not gonna do anything, I think. Or it's gonna shift by 0 to the left, but I'm not sure how that works either. Because you wouldn't that be 1? Not really sure. Obviously, just based on the name, I can infer that it is testing to see if it is set, but I don't want to clarify the bits there, the bitwise operations. I'm gonna try to go F10 on all of them now. Go faster. Seems like it taking a lot of time to do everything there. Okay, finally. This will be 9,000. And I think that the arguments are on the arguments that were sent to this command, or to initialize the executable are here. So it is working. I roughly got it, but well, another thing that I'm thinking about is maybe maybe not today, but at some point going slower on these assembly parts and then copying all these hex numbers and asking GPT what exactly they are. If there is anything specific about them. So I think I'm just gonna send the questions to GPT. And then I'm gonna go just on the entry point function there, or implementation of args, just see the whole thing instead of stepping into. So the main thing here, like you can create, based on what I'm seeing here, the way that I think it works is that you use this parser here, which is probably a struct based on the color. And then you use this macro, and then when you use this macro, it allows this, it probably uses the imp index, which implements functions for this struct. And that's how you can call the parse function here. Then you use this macro to determine what arguments you can send, I think. So in this case, it would be the part argument. But as I was saying there to GPT, is that the main thing one of the main things that I wasn't sure and still is kind of confusing to me is what is the relationship between the name here that you put here and the flag you pass through the command as you're running the executable. That's kind of ambiguous to me. So the parser is a trait, not a implementation. The trait is kind of like an abstract class on other languages. It's basically a template of functions you have that you can implement through other structures. So yeah, I think that's the main difference between Rust and C++. On C++ you have classes, and classes are like the combination of a trait with a struct. So it's an object that has functions, and on Rust they are separate by default. So the struct is just the object with the values, and then the trait is the template of functions, and then you use the implementation keyword to implement traits on structs. So this favors more composition. So you can have, the way that I think about it is the objects being like an island, and the functions being boats across islands. So on C++, they are connected together, but on Rust you can have like multiple different variations. You can have multiple implementations, like multiple relationships between objects. I think probably neither one is best. Depends on the context and the constraints. But I think this influences a lot what you build with the language. You can do both things. You can do composition on C++ and you can do object-oriented on Rust, but it goes against the language, I think, the nature of the language. It probably forces you to use more memory, I think. This is another thing on Rust. Like the downside of Rust is that you use a lot more memory because I think it's something called monomorphism. What this means is basically that Rust resolves the generic types into specific types on compile time. So when you have these generics here, it's gonna implement like a different rate for each one. It's like fixed. And this is good on runtime because then obviously you don't have to resolve. So it becomes faster at runtime. But then the trade-off is memory. And I think that's why usually Rust projects are gonna be very big. They're really bad thing because like some of them can easily take like 200 gigabytes of memory. This is a lot. Oh, so it's basically just getting matches based on the. It's hard because I can't go to the. You can go manually or just search there on the VS Code. But the question is how does it get matches, and it's gonna be on the parser there. But this is another annoying thing on Rust is that usually when you go to the definition, it's kind of hard to know. But because you have this composability where you can have multiple traits for one struct, when you press F12, usually you go to the trait definition, but then it's kind of useless because you don't really know like what is going on. You only know the translation between types, but you don't know what's actually happening on the function. And I think that would be fine if it was impossible to have side effects. So if you have a functional language, it makes sense to only have the types. But when you don't, then it becomes an issue because you never know if there could be side effects inside of the function, which would change the behavior. And also, this is another thing that I was like one of the things that I wanna try to improve at that there was this one quiz about on the website that I have there, but that I think I'm gonna probably have to dive deeper into the compiler to clarify is the resolution of traits. So there is something about this on the book as well. I think like for example, when you have multiple traits for one struct, then how does a compiler resolve which one is gonna use? And I think that's on the like if you define a trait for a type that already has like the same function, then it's gonna choose the one you defined. But then there's some situations on like the built-in library that doesn't happen because then obviously you would prevent everyone else from like changing the behavior or something like this. Yeah, I think that basically what it's saying, and I agree with it, is that I should, instead of having the agent, maybe I still should have the agent build the configuration, but I should manually go over the entry points. So I should probably first have the agent clarify what are all the entry points that I can use on the library that I'm going to study. Then understand, manually go over the main file or all the entry points that the library has to understand how the, or maybe read the documentation as well, understand how to call the library. Then I manually create main RS. I should create my own main RS file that uses the library. That's probably better, because then I control what type of arguments I'm gonna call the library with. Or actually, I have the agent use the local library on another crate. Then I debug that crate instead of the original library. And that's probably better. So obviously, depending on the library, there are going to be several different ways to use it. So I should have like have the agent cover like all the main use cases on the main .rs file. Then it's gonna be easier to understand. So the shift, I remember correctly. So let me think. I'm gonna stop here, but I think that's probably next time that I stream. I'm going to do, I think off stream, I'm gonna try to do like use the agents to set up. That's probably like the best thing to do is probably to create my own main RS files that call the libraries first. Yeah, and I should combine that with the exercise. That probably is the best thing. So I have DeepSeek do his own labs. The question is, maybe I create another folder here. That's probably the best thing. Because then on each folder I can have specific types of exercise based on the libraries. Hmm. Like I have the agent. Yeah, I should, like for each library that I'm going to study there, based on the frequency, I have DeepSeek. I talk to GPT first, then create a prompt to have DeepSeek create a file or a main ARS file with all the use cases for the library on the labs. Then go over with the debugger from that library, from my own main ARS. Then after that, create exercise based on the first pass. So like I have questions first, then I create the exercise based on that. Clarify the questions, then create the exercises. I think for the first 5, I'm going to follow the order that I already have here, but then because I have to refactor the commands there, I'm gonna do like this. But then I'm gonna follow this probably the order here from the report. And ideally, I think this like should be the first thing that I do, but then on the other files I create exercise based on this as well. Separate because I need ones that are per library to study the library in depth. But then after each one, I extract like fundamental principles, and then I immediately create exercise based on the fundamental principles. That's gonna like reinforce everything, I think. So next time, so I'm gonna probably have GPT now. I'm gonna discuss this with GPT and then have DeepSeek implement this main my own main RS files for these 5 libraries here to create with all the use cases or like covering a bunch of different use cases for all of them. Then next time I'm going to go over with the debugger on these libraries from my own main RS and then create questions and then start from those questions already creating, like trying to build my own version without the agent. And then after that, I maybe write down on the other projects what exercise I could do that are gonna generalize from that to everything. So yeah, see you next time.